Most of us have seen ships in some form or another, but do you know how they are made? Today, we'll step inside a shipyard to gain a detailed understanding of the entire shipbuilding process. I'll take you from raw materials to the vessel setting sail, so the video might be a bit long. If you're interested, feel free to watch patiently. Now, let's begin. What you see here is the ship hull mold. To build a ship, the first step is crafting the hull, and the primary material used for this is fiberglass, also known as glass wool. Workers cut it to the required dimensions. You might wonder, how can fiberglass alone form a ship's hull? Well, it can't. That's where another material comes into play, unsaturated polyester resin. This is a composite coating similar to epoxy resin, often used in construction due to its high strength. When combined with fiberglass and dried, it forms a new material called fiberglass reinforced plastic, FRP. Think of FRP as reinforced concrete, where fiberglass acts like the steel reinforcement and resin as the cement mixture. Applying FRP to the hull not only increases hardness but also provides fire resistance. Most importantly, this material is lightweight yet strong, making it ideal for hull construction. The hull you see here is made entirely of FRP. To achieve the required thickness, layers of fiberglass are laid, up to dozens in some cases. The number of layers varies. For small boats, around a dozen layers suffice. Polishing and sanding seem time-consuming, taking up to 2 days to achieve a smooth surface, which ensures better paint adhesion. Next, the bottom plate is installed, followed by the deck, which is built similarly to the hull, also using FRP as the main material, applied manually layer by layer. Removing the mold can be tricky. Workers start by tapping along the edges to create gaps. Although the resin has dried, it remains quite adhesive, so external force is needed for removal. Despite the deck's thin appearance, its FRP construction makes it as strong as ordinary steel. Protected by the hull, the deck doesn't need to be as thick. The deck here features a keel structure for added rigidity and load-bearing capacity, which is crucial as the ship's bottom must endure seawater impacts while carrying fresh water and fuel. As the foredeck is installed, you'll notice not only the deck's keel but also the dense ribs of the hull. With the foredeck in place, the middle and aft decks follow. These sections are heavy, requiring cranes for transport. Once the final deck piece is placed, the workers wrap up their day. The next step is finishing work. Workers use grinders to smooth out the fiberglass, taking precautions to avoid inhaling dust. Later, the hull will be coated with paint, which adheres better to a polished surface. As the day ends, we move into a new phase of construction. This triangular structure at the bow is called a bulbous bow, designed to reduce water resistance and improve speed. The bridge deck is also installed, and workers continue surface polishing. Resin acts as an adhesive, bonding sections together firmly once dried. The ship's engine is its heart. The pristine engine you see here likely carries a hefty price tag. Alongside it is a generator, much larger than household versions. Despite its proximity, equipment like cranes and trolleys are used for handling, a testament to teamwork. The engine is installed inside the engine room, with its cover removed. Ship propulsion comes in 3 forms: mechanical, sail, and human-powered. Mechanical propulsion, typically diesel-driven, uses a propeller to move the ship. Sailboats rely on wind, while human-powered ships depend on physical effort, such as rowing or paddling. Ever wondered why commercial ships use diesel instead of gasoline? Unlike on land, ships don't require high RPMs but need high torque to overcome water resistance. Diesel engines excel in heavy load applications, like trucks on highways. Additionally, gasoline is more hazardous, posing risks during long voyages. The massive propeller shaft is installed next, connected to the engine for power generation. The propeller itself is heavy, often requiring tools for lifting. Workers align it using a hoist, and 2 men spend considerable effort to secure it. The nuts used here are enormous, roughly as thick as an arm. Back to the hull, the bridge's accessories are installed. The mast, a tall metal frame, supports signal lights and serves as a lookout. Historically, masts were wooden, varying in height with ship size. Today, their role has expanded. Signal lights are mounted on the mast, and the bridge's interior parts, also made of FRP, are cut and fixed with nail guns for efficiency. Wooden panels enhance the ship's aesthetic. The deck is installed again, with additional keels and ribs added for strength. Fiberglass and resin are applied to seal gaps, hardening quickly and securing the structure. A border around the bow improves both durability and appearance. Inside the cabin, workers spend hours sanding, a task that tests endurance. A metal cover is fitted around the smokestack, possibly for safety. Most external parts are now in place, and the focus shifts to finer details. The windows are made of toughened glass to withstand harsh weather, and all fittings are secured with screws due to FRP strength. The doors are specially treated with thick frames, sliding open to resist strong winds. Wooden panels line the bridge's interior walls, adding elegance. Adding insulation between gaps could reduce noise, a thoughtful touch. The interior hardware is then installed, including the control console. A wooden steering wheel would feel more authentic and easier to turn. External metal frames are installed for protection, fastened with screws hammered in place, a quick and efficient method. Various equipment is then installed, including a large radar display for navigation assistance. 2 months have passed in construction, a stark contrast to modern car production, which takes just a day. We return to the shipyard for the final touches on the deck and exterior. Wooden planks are laid for the deck, a material not typically used in fishing boats due to susceptibility to mold and cracking. The ship's railings are welded meticulously, and the wooden planks fit seamlessly, showcasing the craftsman's skill. Next, 9 tires are installed as fenders, providing shock absorption and protecting the bow from collisions. These tires are common on many fishing boats, offering a cost-effective alternative to specialized fenders. After waterproof paint is applied, the final details are addressed. A crucial component is the toilet, essential for long voyages. Larger vessels often discharge waste into the sea, though the exact method here is unclear. With construction complete, the ship, weighing about 30 tons, is carefully lifted into the water by a crane and transported by a flatbed truck. It's unclear why this is done on a rainy day, given the importance of weather conditions. The final metal cover is installed, marking the ship's completion. Finally, it's time for testing. The ship moves smoothly, its wooden deck exuding elegance. What do you think a ship like this would cost?